Okay, so now that we know what the sine function and cosine function look like on the Cartesian plane or coordinate plane, we're going to start most likely your favorite, graphing transformations. If you're coming from 111 or your algebra days where you had to graph transformations, I promise you in this class, it's way better. It just is because the functions we work with, sine and cosine, they have an upper bound and a lower bound, which make graphing much easier. So I'm looking here and I'm going to use Desmos to help me fill out this chart. Okay, so I have three different functions. I don't know what these graphs look like because we haven't been taught that yet. So I'm going to go ahead and go to Desmos. My first one is negative 3 sine x. So I'm going to put negative 3. Let me actually do. Nope, sorry. Let me go ahead and do y equals negative 3 sine. Where's my variable x? And I'm going to close this. All right, so there's this graph. Looking here, it's kind of hard for me to compare because of my scale. So I'm going to change my scale. I'm going to change my scale to go from 0 to 2 pi. Because then it's going to be much easier to compare it to my normal, or my parent function, I should say. Okay, I'm going to go ahead and delete this. And this I'm going to go from like negative 2 to 2. Make sure you're in radians as well. Okay, so then it just gives me a better scale. Oh, no, let's go ahead and make my step. I'm going to make it be the same as when we plotted in the previous video, which means every tick mark is a pi over 2. So now, I'll get a better look at this. There is my graph, okay, for this function. So we can see a midline. Hopefully you can understand where the midline is, and that would be at y equals 0. So if I look at my midline, then I can see that my height of this graph, the highest it goes is 3. And then let's also talk about, again, you start anywhere you want. I like to start at 0, 0. We went down, hit the x-axis, went up, hit it again, and we start repeating, what do you know, at 2 pi. So what that tells me is my amplitude was 3, because remember, sure, I see a negative there, but amplitude is always positive, and my period is 2 pi, because that's where it started repeating. Now, if you go ahead and plot 2x, or sorry, forgive me, 2 sine x, so y equals 2, my function sine of x, I'll close it. Well, here you have a green graph. Here's my midline, cuts it right in the middle, still at y equals 0. And the height it goes to, if I select that point, is 2. And let's talk about the period for the green graph as well. I start here, I go up the roller coaster, hit it again, come down, hit it, and I start this cycle all over again, starting at 2 pi. Going back. So my amplitude, 2, period, 2 pi. So let's just make a guess if going off these two, well, it looks like maybe my amplitude should be 1/2 and my period should be 2 pi. Let's make sure that's true. So y equals 1/2 sine of x. And what do you know? My height is at 1/2 or 0.5. And my period, if I start here, I go up, down, 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 hit the x-axis again, and start the cycle all over again. So my period is still 2 pi. Okay, so we're good. So what hopefully we're noticing is when you have this value in front, this, that matched your amplitude. So when A is bigger than 1, we saw, let's go back to so I can convince you. So this is where A is bigger than 1. It looks like the graph got taller. Does that make sense? Like even the blue one, right? So what we say there mathematically is it vertically stretched by a factor of whatever A was. When we saw that it was 0.5 or 1/2, it got smaller or shorter, we could say, but mathematically we'll say it vertically compressed by a factor of A. Now, when A, this should actually be when it's less than 0, so change that on your notes. When A is less than 0, which was this case, going back, we're going to look at the blue graph, and I'm going to compare it to our original graph, which is known as our parent function, so just sine, I forgot my equals. Well, yeah, the graph got vertically stretched, but didn't it also flip, right? From black to blue, now it's flipped over that x-axis. So when you have a negative in front, again, make sure that you change that to a 0. This means it's reflected about the x-axis. So I'm never going to say my amplitude's negative because my amplitude, again, is just talking about the height from the midline up. So it's always positive. But if it is negative, it's talking about a reflection as well. So that means there's two transformations happening. So we're going to go down here and graph. All right, so it wants me to graph this function and then also this function. And so hopefully graphing these are going to become very easy. So I'm giving you an open scale. We know for this function, my amplitude for f of x is 1 because there's nothing in front. Or we could remember from just the notes. And my period for sine of x is 2 pi. So I like using this to help my scale. I'm going to make 4 tick marks, 1, 2, 3, 4, and my 4th is going to be my period. And you can make, this scale anything you want because it's a tiny graph. I'm going to make my second one be a 1. So that means my second one down here has to be a negative 1. Sine, we talked about graphing those 4 or 5 key points. So I'm going to go 0, 0, 1, back to the x-axis, hit this, and then hit this. I should always do 2 full periods, so on the other side I'm going to continue the pattern or use my unit circle if it's still not clicking. And so here, again, making sure those peaks and valleys are not points and making sure I have arrows. There is my graph for sine of x. And again, that's from the previous video. Now we're going to talk about transformations. Well, when we have a value in front of our function, that turns out to be our amplitude, but our amplitude is always positive. And our period for this, well, we haven't seen a change yet, and again, we could go to graphing using a graphing calculator because this is brand new to us, and see the fact that our period is 2 pi. I'll show you after we graph this. So, all right, I'm going to use that to help my scale. So that's going to be 2 pi. And I know there's a negative in front, and we're going to talk about that in a second. Well, my amplitude is 1/2. So I could make it like really tiny, but it's going to be hard to see. So I'm just going to happen to make this one be 1/2. Again, you can make your scale whatever you'd like. So that means this second check mark would be my -1/2. So I know that sine, I'm going to ignore for a second, ignore this negative. I'm going to, at the end, talk about it. So I'm going to pretend this is just 1/2 sine of x. Well, my sine starts here and it ends here. But now my height of my function goes to 1/2 and it goes down to -1/2. I put that in the wrong spot. So it goes to the height is 1/2, then I hit the x-axis and it goes down. But I haven't talked about that negative, right? This negative talks about a reflection. So what I need to do is I can't reflect the ones on the x-axis because they're on it. But I can reflect this one to now going down here. And I can reflect this one to going up here. And now what do I have? I have this reflection, which again was talked about in a previous class before 112. And now you could go ahead and put in these points and try to figure it out, but it has to follow this pattern. So my next one has to be a high point. My next one has to hit the x-axis. My next one has to be a low point, has to hit the x-axis. So there's that. So let's check. And again, this looks kind of similar to this one, but my scale makes it different and the reflection. So just to check it with Desmos, I'm going to do y equals -1/2 sine of x. And hopefully it looks the same. And you could double check your coordinates. So I should have 0, 0. I should have pi, -2, -1/2, pi 0, and so forth. So if I check going back, yep, looks like I have the same coordinates. So the takeaway from this video is being able to look at the function and taking out what the amplitude is.